Dear students, let's complete our exercise A. We have the sixth question. Is A plus B plus C equals to A plus B plus C, that is equal to B plus A plus C? Question mark. So what you need to say? Whether A plus B plus C equals to this and this equals to this. So what will be our answer? So our answer is yes. So how you can say answer is yes? Because when we see there are three set of whole numbers. We have A plus B plus C. Okay, the same numbers are here, but the grouping is for B and C. So when you go to the next step, again what you can see here. So here we see the number B and A are added. Here B and C are added, but the order of the number and the number value of the number is same. So anyhow you add, the answer what you get here equals to the answer what you get here and here. So all these three answers will be same. So our answer is yes. So let's move to the next one. Which property of addition is satisfied by? So they have given us 7 questions and we need to say these questions and say which property of addition it is satisfying. So when you see 8 plus 7 equals to 15, so which property of addition will you remember when you see this? Yes, the first property, that is the closure property. What you have studied in the closure property? X plus y. Yes or no? We have studied the closure property x plus, there are two. Okay, if there is a y, x value and the y value, we get x plus y. So, x plus y is the answer we got here, 15. So, this is the value of x and this is the value of y. So, x and y equals to x plus y. So, it is 15. So, what property is satisfied here? It is given x plus 5. X plus y equals to 15 or 8 plus 7 equals to 15. So, which property of addition it is satisfying here? You should write it is satisfying closure property of addition. So, this should be your answer. So, which property it is satisfying, children? It is satisfying the property used here is the closure property of addition of whole numbers. Closure property of addition of whole numbers also you can write. So, we have written here now closure property for addition of whole numbers. Okay, for addition of whole numbers. Of whole numbers. Okay, this you need to mention. So let's move to the next one. 3 plus 5 plus 4 equals to 3 plus 5. So here what you can see, here we can see that any set of whole numbers, so what you can see here, 5 plus 4. So this two set of whole number is good. And here that is the first and the next, that is A plus B. Your B plus C and here A plus B. They are grouped. So what you can see, which property you can apply here. So it belongs to which property of addition. So when we solve this, you get, just let us solve here, 3 plus equals to 3 plus 5 plus 4 is what? 9. Yes? And here you solve your 5 plus 3. How much? 8. No? 8 plus 4. So you add this both, 9 plus 3 and 8 plus 4. What you get? 12 equals to 12. So when you solve, you get the answer same. 12 equals to 12. So which property of addition it is satisfying? So it is satisfying here associative or associativity property for addition of whole numbers. So you need to remember this. So it is in the form x plus y plus z, and you can see we have group. So here it is satisfying the associative property for addition of whole numbers. Otherwise you can write associativity for addition of whole numbers also. Let's move to the next one. So what do you have here? 8 into 8 plus 0 equals to 8 into 8 plus 8 plus 0. So when you say this, so what can you understand? Which property may be applicable here? Okay, so the property which is applicable here is the distributive property of multiplication over addition of whole numbers. So how you can say distributive property over addition of whole numbers is satisfied here? Yeah, because the numbers what you find here, they have been distributed. Okay, distributive property of multiplication. So they have divided in a multiplication form of addition of whole numbers. So we can rest. If we go to solve this, so what we will understand, what we will obtain, let us see. 8 into 8 plus 0. What is 8 plus 0? 8. So let us solve here. 8 8s are 64. 8 zeros are 0. So what answer? 64 equals to 64. 64 plus 0 equals to 64. So what you can say? Which property? Distributive. Remember. Okay? Distributive property for multiplication of over addition of whole numbers, that you can mention. So you can write distributive property of multiplication or distributivity of multiplication over addition of whole numbers you can mention. I have just written here distributive property of addition of whole numbers. You can just copy it down. So next let us move. 7 plus 6 equal into 10. 7 into 10 plus 6 into 10. See this case and the below case. So the fourth one and the third one looks just as similar. Yes or no? Yeah, they look similar. But now what you need to mention here? Here, even though it is a distributive property, if you go to solve this, you get the left hand side and right hand same. So what you can write here? Distributive, which properties you can solve this, okay? Distributive property over distributive property of multiplication of multiplication over addition of whole numbers. So did you understand the statement why I have written here? Yes. Distributive property of multiplication or addition of whole numbers. Why I mentioned this? Because property of multiplication means what? It is using the multiplication property over addition. So this is called over addition of whole numbers. So next let us move to the number 5. 15 minus 12 into 18 equals to 15 into 18 minus 12 into 18. So same as this one, children. So what you can see here, they have used multiplication and over subtraction. Here it is minus. So what you can say, this also is a distributive property of multiplication but over subtraction. Why it is subtraction? See, it is not addition. It is using the subtraction minus symbol. So what you can write here? What it is? If you go to solve, what you can say? It is the distributive property of multiplication over subtraction. Understood why it is subtraction? Yes. Of whole numbers. Okay. With my handwriting you need to understand. Over subtraction of whole numbers. So this is the 5 we have completed. 5th we finished property. Let us move for number 6. So what we have, 16 plus 0 equals to 16. So when you see here, what you can find? We have here 0. And what you know, this 0 is in the property. 0 is called to be the additive identity. So what you can write here? So what property is used here? As 0 is the additive identity, or we can say it is existence of identity. So there is a existence of identity. So which is existence of identity we have? 0. Existence of identity or additive identity, the property has been used here. So we can say existence of identity. That is 0. Otherwise, in other words, what you can say, children, in other words, we say additive identity. 0 is the additive identity. So in other words, you can say 0 is the additive identity. So next, number 7, you see 23 plus minus of 23 equals to 0. So what you can observe? Here it is minus 23 and here it is plus 23. So which property is being used here? Can you just remember and tell me which property is being used there? There we have used the additive inverse property. So we have used the additive inverse property, children. So why? Because the sum of the numbers is 0. When you go to solve this, what your answer you will get? You get here the 0. So what you can say? The property used here is additive inverse. So additive inverse property. So this is the additive inverse property. Okay. We can mention, otherwise you can write the sum of the additive inverse is 0, or else in other words you can say the property is additive inverse property is being used in the number 7th one. So we have understood here the solving, we have identified how to use the properties of addition, and it is satisfied by which property we have understood here in this exercise. So let's move for stating true or false. Let's learn now true or false. We should state the statements are, the given statements are true or false. So here we have the 12 statements given. So let's read one by one and state whether the statements are true or false. So the first one we have, the sum of two odd numbers is an odd number. So the sum of two odd numbers is an odd number. So what is the answer for this, you think? So the answer is false. So the statement is false. Why is it false? Because the sum of two odd numbers is an even number. So you take two odd numbers and you add them. So what you will get if you take odd number and add 1 plus 1? You add what you get? 2. So 2 is an even number. So how you get 2 as an even number? Same way you go on adding the odd numbers, and when you add the odd numbers you get the even number as an answer. So this statement is false. So number 2, the sum of two odd numbers is an even number. So here they are asking now the reverse order of it. So reverse order. Here they had asked order, they are asking whether it is even. So as I explained to you, this statement should be true. Number 3. The sum of two even numbers is an even number. Whether the sum of two even numbers. Take 2 plus 2. What is the answer? 4. So if we add two even numbers, answer is also even. So our statement is true. Number 4. The sum of two even numbers is an odd number. Now you need to take two even numbers. Take any 6 plus 6. So 12 is an odd number. You take two even numbers and you see whether the sum answer what you get 12 if it is an odd number or an even number. So when you add, what did you get? The sum of two even numbers is an odd number? No, it is false. Because why is it false? Let us see why is it false. Because the sum of two even numbers is even number. It is not odd number. So the sum of two even numbers should be even. So this statement is false. Fifth one. The sum of even number and an odd number is odd number. Okay, the sum of an even number, take an even number and an odd number. Okay, take 2 and 1. So, whatever answer we get, that is 3. Is it an odd number? Yes. It is an odd number? Yes. Surely it's an odd number. So, 3 is an odd number we know. So, our answer is true. Next, number 6. Every whole number is a natural number. Every whole number is a natural number. Every whole number is a natural number. What you can say? Every whole number is not a natural number because every natural number is a whole number. Understand? Every natural numbers are called as the whole numbers, but every whole numbers are not the natural numbers. So what we can say? The statement is completely false. So I think you have understood. What you do you understand? That every whole number is not a natural number. So our number 6, we have the statement as false. So I am here. Let us write here false. Move to the 7th one. Every natural number is a whole number. So every natural number is a whole number. What you can say? It is true. If this is false, then this should be true. Number 8. Every whole number plus 0 equals to the whole number itself. Yes. When you take any number and you add 0, what answer you get? The number itself. So this our number. It is true. You take 7 plus 0 or 10 plus 0, we get the whole number 10 itself. So these are our answers. I am just underlining to avoid confusions. Okay. Now number 9. Every whole number plus 1 equals to the whole number itself. You take any whole number and add 1 to it. Now 9 you take and add 1 to it. So whether the answer what we get is 9? No, it is not. Now what do you need to say? If at all every whole number plus 1. Okay, every whole number plus 1 is a whole number itself. So here what you can say, when you take a whole number and you add 1 to it, so what you get? The whole number itself. So whatever answer we get, that is also a whole number. Yes or no? Yeah. So what we can say, this statement is true. Okay. So here what I said, take a whole number, add 0. So the whole number itself you get here. And here if you add 1, the whole number you add 1. Okay. If you add 1 also, it remains as a whole number. Yes. So our statement is true. Number 9. Number 10, let us move. Commutativity and associativity are properties of natural and the whole numbers both. So what can be our answer? Yes, the properties are for also for the whole numbers and natural numbers. So our statement is true here. So number 11, commutativity and associative properties of addition for natural numbers and both whole numbers also yes, surely. So it is also true. So number 12, if x is a whole number, the minus x is also a whole number. So what you can say, if x is a whole number, minus x is also becomes a whole number. So our statement is true. So I hope so you have understood all these 12 true or false. So you need to copy down this true or false in your notebook neatly. Thank you.